Later. Okay. All right. So let's quickly walk through part two, and we continue from our tricks. Part one, we did quite some good work, but quickly, let's look at now. When it comes to trick graphs, what are the most important things? 5 minutes note again. Graphs. Understand that we have how many types of graphs? Three. Sine, cos. Okay. So if I tell you f of x is equal to x, or let's say sine x plus q out here. K determines the period. So period will K. Let me divide the board into three and see if I can do some. Here I'm looking at a sine graph. But 360 over K. What about your Q? What does your Q stand for? Vertical what? Shift. Plus means we go up. Minus means we go right. So please, what is the minimum? Sine kx. Okay, so if I say plus q, what will our minimum be? Q is, because we, right? We would have shifted. Okay, what about the maximum of sine kx? There's something I forgot. Okay, what? Maximum is 1 plus what? Q. Okay, can I change something quickly? Can I change? Here. And right. If I have a sine kx, then what I should, let me just change this a bit. The minimum would be what? Minus 1 times a plus what? Q. Check. The minimum of a sine graph is -1, right? A normal sine graph is -1. I'm putting an a in front of it. What does the a stand for? How do we get the a? Half minimum, maximum minus minimum. Okay, no, divided by 2 would give you a. Amplitude. I'll write that down. So again here, the maximum of a sine graph is what? 1. But if I have a, I'll multiply that by a and I add what? Q. What is a? My a is the amplitude. And what do I know about amplitude? It is always what? Positive. So a, it is 1/2 maximum. We can combine sine and cos graph. Let me just do that because it acts the same way. So all the information I have here would work for sine graph and a cos graph. What is the range? Referring to y values, right? Minimum less than y less than or equal to n will be your what? The x values. N will be the x values. Just a short note to put everything together, right? Okay. If I were to have a 180 and 3. I want to have a sine graph. You know what the 90, the graph would be what? That's my sine graph. That's a complete graph. That's 360. Is that okay? How to find period and how to find K. I give you the graph of sine X. What is the period going to be? K is 1. It's 1x. What about if I give it 2x? What is our period going to be? Okay. Our K is what? 2. So sine half x. What is that period? All right. 360 divided by half. That will be equal to what? 7. Same thing happens with the cos. Must know the mother graphs of each of these things. Depending on what the examiner wants you to do, what do I know? Cos 0 is cos 180 180 negative 1 and 360. Graph can be shifted, the graph can be expanded, the graph can shrink. Well, so many things can happen to the graph based on A. A is the amplitude, it will affect the minimum. Q is the vertical shift, graph up or down. What about K? K will tell us whether the graph is shrinking or the graph is being bigger the value of K, the smaller. Stretcher the graph becomes. K is beginning to be big. It means we are. K is small, we are expanding. Right, so I think this would help quickly. And that of a 10 graph, so I'm just trying to put everything on one page, and then we can look at one or two questions. Graph, what do? Know that it has an asymptote. This is the only tree graph that has n kx or tan x. What are your asymptotes? The period 180 over k. And the period is also the distance between two asymptotes. Distance between the asymptote tells you it's an error. The graph does not what? Exist at that point. graph doesn't exist at that point. That's just a quick summary. Perhaps we're going to answer questions and then we'll can talk about when we talk about. Okay. All right. Can we continue? Can we try to look at the question? Oh, sketching graphs. Do you know how to sketch graphs? A table. Okay. First thing, before you even go to the calculator, first you must get your steps. Depending on the function now. Step sine kx and cos kx 90 over k for both of them. And kx over 2k. Right. For sine, cos, okay, no. Guys, this is what we'll do. We don't. Guys, this is what we are going to. This. Ninety over k for both sine and cos, and k if it is what 10. Okay, and then your start and what end would be controlled by your okay. Finally, before we look at the question, for one, if we reflect along the x, what do we do? Keep the x, but change sign of the y. Keep the x and change the sign y. So if, for example, f of x is reflected, reflection along y, keep the y and change the sign x. So what are we going to have? So f of x is y happens f of negative. Where we see the x, it becomes what? A negative. In paper 1, we're doing f of x multiplied by Kate lose marks. Careful, don't run, don't rush your paper. You have enough time. Thanks for sacrifice. Right, so we'll go look at a graph. We'll go look at a question quickly then. Okay, take a picture. Can't even write fast to save your own life. Good. All right, quickly look at this. Given the function negative 3 tan x, sketch the grid, sketch on the grid provided, blah, 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 between 0 and what? 360. Before you go ahead, what do you need to do? Deal with steps. What's our step in this case? No, it's a tan graph. Check your table. 90 over what? 2k. What's your k? 1. No. K is the number, is the coefficient of x. Remember, I said tan kx. 1. So you have tan x. It's basically saying tan 1x. What is my step? Step should be what? 90 over 2 times. Okay, 0 to 360. Let's sketch together very fast, as quickly as we can. 0 to 360. Let's sketch. Use your calculators. So let's get a, because I'm going to take my calculator off. So I need you to work with me with your calculators. What do we press? Mode. Table. What's the negative 3 tan x? Make sure the bracket is closed. Put together x from right. Plus 2. What's your start? 0, 360. Step 45. Graph must look like that. Graph must look like that. Check what are the values we need for the y. 0, negative 3, error. 3, 0, negative 3. So basically, are we okay there? All right, so value will be given your own grid. One grid here quickly. 0 to 3, 6. Right, 0 to 360. So that our step is what? 45, right? So I'm going to count 3 boxes to give me 45. One what? 35. What would that give me? 5, 70. Asymptotes on the calculators, the way it says error, you said what? 90 and 270. What do? We draw straight. And 270. There we go. Okay, I need to shift my. All right, and you notice we're dealing with 3, right? But you want to give me the values? At 0, 5, and -3. 90 is an error. 135 and 3 there. 180. 70 is an error. 350. 360 is 0. So you your graph already. Can you see the shape already of a graph? Remember your asymptote graph. Not much of a straight line graph. Graph shouldn't be longer than your asymptote. Quite long, so that you can have I use a pencil so that if you make it, that's your tan graph quickly. Make sure you arrow there to tell you that you're. By the way, what's the range of a tan graph? Positive what? Infinity. The range of a tan graph. So if you look at, for example, examiner gave you this graph and tell you to find the period. Look at what I would have done. Quickly look up. I look at my asymptotes. 70 minus 90 would have given 180 degrees. That's my period. That's why I told you it is the distance between two what? Asymptotes. What? Asymptotes. Okay, we got to run. It's just to got the point, and your calculator, whatever graph they give you, you just walk through. Let's see this. Oh, write down the period of f, which we've done. Section of f about the x-axis. 5.1.2a, we said our period is what? N 80. What about b? Reflect about the x. What do we do? Keep the x and change the y. So what do we have? H of x. Remember, it's going to be negative f of x. Negative 3 tan x. What is negative times negative? Positive. Tan x. Quite straightforward, not too hectic, right? Okay. If it's a sine graph, you know what the shape would look like. If it's a, just look, trust your calculator on this. Don't make error, and also know what the shape should look like in your head. error, you know that. There's things here from China. So let's look at this. Sketch below is the graph of that. Write down the value of A and B. This graph is A cos BX. How do we get A, by the way? 5.2.1. A talks about the amplitude. My maximum minus minimum divided by A would be what? 1 over 2. What's the maximum? 2. Minus negative 2. Or divided by 2. 2, really. You have your calculator. But B. What is the value of B? B tells you the period. You see, they used B, but I used K. So it could be a different, right? B and K. Now, what's going to be B? The value of B? 360? No. Okay, here. I said period. It's a cost graph, right? Will be 360 over B. Are you sure? That's what we're looking for. We're looking for the value of B. Ways. Check your full graph. Do I have a full graph here? That's a quarter. Right? So this is a full graph. Do we agree? It's a full cycle ends at what? 360. So I would go and say, okay, so the period of this graph is what? 360 equal to 360 over B. What would I divide by 360 to give me 360? 1. So don't guess. You need to just don't guess. I don't want you to guess. Or alternatively, you would do what we did in the first session. Look at what I'm going to do. Let me see how this one works for me. Let's look for a point where we know the coordinates. Can you find a point for me where we know the coordinates? Okay, 90 and 0, or that. This one here, our x is what? Negative 2. Y is what? Sorry. No. Our x is what? 0, and our y is what? Negative 2. What is the point here? Let's just use any of those 2 points first to see. We're saying g of x, right? Which is y. Do we have our a? What is a? Cos b theta. Just replaced my a. Make sense? By the 0 and negative 2. What's my y value? Cos b, what is theta? That one would not work for us. X is 0. Let's use the other one. So we cannot use that one. What is my y again on the second point? 0. X is 90, y is 0. I don't want my x to be 0. That's the y cannot x. All right? 2 cos b multiplied by what? 90. Right? Can I divide both sides by 2? So what do I have? 0 equals to what? Cos 90b. How do I get rid of the cos? What would it be? It would be arc cos of 0 equals to 90b. We did this when we were looking for angle. What is arc cos of 0? Check your calculator. Don't remember using that other method. You can use this one where you find a point on the graph. But remember, your x must not be what? X must not be 0, so I cannot use this point. X must not be a 0. Use the graph to determine the values of X for which G of X. What? Y should be what? Greater. Y, the graph should be above the X axis. Huh? 90 and 270. So our answer here, 9 less than what? 90 and between 90 and 270. Determine the range of H. If H is down 2 units. So range, remember our range is what? Between minimum and maximum. Are we together? All right. So H of X. Remember our range is what? Minimum less than Y less than what? Max. Before we go to H of X, what is our range for F of X? Now, what did we say? H of X is F of, that's how they can write it for you like this again, minus 2. Down, how many units? 2 units. Right? We just subtract 2 from those values, that's all. 4 less than Y. So you shift all the values down by what? By 2. All right, determine using the graph the value of this. This is very. Now, they said, are you going to plug? Do you know this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 dots means the values continue forever. Would you finish your paper? Okay. Let's try to study the graph quickly and see what we can make, if we can make some sense out of the graph. All right, let's check. This examiner is quite clever. Number 5.2.4. Negative 2, definitely that's going to stand. Now, what is cos 0? Y value is negative 2, right? There. All right. Y value is negative 2. I wanted to check something. What about cos 1? Cannot. No, there is, but can't because there are too many. There are 90 of these lines here. Way too small, right? So let's be smart a little bit. Look at this. Because you will notice we're starting from 0 to what? 3, 6. That these values are all negative. Okay, let me just paint it. Values are all negative. And these values here are the positive of these negatives. Does that make I lose you? That these values are negative, but these values are the positive, so of all of this. So this whole thing, if I add this, gives me 0. Okay, hold on. Let's go back. Let's go back. I pick 1, for example, it's negative. Where above -2, right? But this value is also cut out from here by the value. Okay, check. Okay, check first. Let's check something. -2 here, right? Cos 0 is -2. What is cos 180? I add that together. What happens? In the same way, if I then start going, this is 180. If I move to 179, one number below 1, 0 and 180. I add them together, gives me 0. 179 and 1 would also be what? 0. What about 2? 2 would cancel out 178. I move down 170 something. This one is going up. That's why I said all of these negative values will end up canceling all of these positive what? Values. And cos 90 that's in the middle will be what? Now, can we do the same on the right hand side? Okay. All right. What is cos 360? Together there? Cos 360 is what? More positive 2. The only positive 2 that I had was cos 180. The cos 180, which is 2, right, has been cancelled out by what? Cos 0, which is -2. All of this is now, we have already cancelled all of this out until halfway. 180, which has been cancelled out by what? Now I have 181, which is same thing as 179. And that would only be cancelled out by what? 350. All of these again will be cancelled out, except what? All the positive values, all the positive values here would have been removed by what? All the negative, except for what? 360. It does, yes. The one that should have cancelled out 360 should have been cos 180. But it has been cancelled out by what? By 0. So all of this gets cancelled out by all of this. All of this gets cancelled out by all of that, except 360. Why are we leaving 360? Because 360 doesn't have a partner anymore. It has been cancelled. It's supposed to have been cancelled by this, but this has been cancelled. So our answer is just, what would our answer be? This is a high order, but it's good. But -2 into bracket cos what? 360. Graph, what is cos 360? You want. You have to punch in cos 0 plus cos 1. You won't. Why? You have to plug it in into 2 cos x. While you're getting that check, what's our function? Our function is what? I equals to what? 2 cos theta. We are using the graph, so it's not just cos theta. We are using equation. That's why we respect. Quite tricky, but this is how of how we. Okay, quickly let's look at this now. This is your Euclidean. The main thing is to prove what? That's the main thing. So what are the properties of a parallelogram? Basically, we're looking at what? Parallelogram. What are the properties? You said what? Opposite sides are what? Parallel and equal. Opposite what? Angles are also what? To prove a parallel, to prove that a shape is a parallelogram, to prove a shape is a part of the time we congruency will tell about the sides. Similarity never tells you that the sides are equal. Similarity never tells you that the sides are equal. Congruency does. And what are the 4 conditions for congruency? Side, side, side. Start changing. See, let me just show you. We have 3 sides, right? Then we start changing the sides into what? Angles. So we can have side, angle, side. I've changed 1. What else? Side into an angle. What would I have? Side, angle, angle, South Africa Airways. Okay. And then the next one, right angle, hypotenuse at the 4 ways. And congruency tells you that 2 triangles are exact copy of each other. Okay, exact copy of each other. And every time you write, you must also write your ratios. Okay, you must also write what? Your ratio. For example, if I, and what's the symbol for congruency? It's like that, right? Okay, so if I tell that triangle ABC is congruent to triangle GEF, what does this tell you? Arrangement is very important. Not just that, that angle A would be equal to angle D, angle order is important. Angles are exact copy of each. One way lies. Sorry, do you know how I remember similarity? S tells me it's similar. How do we prove that? Condition is what? Okay, and if I say ABC to triangle DEF, quickly, what are we going to have? AB. I'm just going to apply them quickly. Following theorems. The opposite sides and angles of a okay. So you want to prove that what? The opposite angles and of a parallelogram are equal. I am going to start gave us these two lines as being parallel. Empty. They equal. Reason. At opposite what? Angles. What else? Let's consider triangles. Let's say opposite sides and angles parallelogram are equal. All right. But that's not going to help us. We need to prove congruency. Wait. You said triangle what? A, D, parallelogram. Angles are equal. Right? That's the first. That's one. That's one. Then, since it's a parallelogram, right? So, which triangle are we using? Let's label the triangles together. And okay, let me highlight because I want it to come from you. All right, ADC. Go ahead again. First, ACE parallelogram. We are given that these two sides are what? A1 is equal. A1 is equal to what? A1 parallel to what? BC. Now you would can we then talk about which round do you mean, child? Or two? Mark the angles that we've spoken about. D2, let me use, right, we said this and this. You said what? D1 and B2 are what? Angles. Right, which line are we talking about? Then say, therefore, triangle. Now, be careful how you label this. You've got to very systematic way. You see, I started from the blue one. Let me start from the blue. But congruent. Order is very important. That how can you see? Check. If we follow the rule that we said, look at this. Then AC. That's why the order is very key. Okay, therefore, are equal. So basically, we're using alternate and common. Trying to prove that this one but here we will always use similarity or congruent, but in most cases, because if we think together, you'd remember. That's what I did, right? Using dots. So when you are labeling, you move from, what did you say? A1. Write down our triangles. Write your triangle down. I can take. Okay, talk to me. The importance of the dots. So I start from the dot. A, AD would be equal to what? That DE, AD, AD, perfect. That's what we wanted to prove. Then, so if you miss the order, you miss what you're proving. What's the next one? All about congruency. Is that okay? About what? Congruence. So know the find X with reasons. Let's quickly get this done. The rest, you just take a question paper, try to. Let's find angle. What are we looking for? Where is X? X. Okay. X. Okay. X. There's no exterior angle. Okay, wait. The first thing I see. Now, however, let's try to walk around. 'But how would I get that value? 185 degrees and 25 degrees. Getting close. What can we do to get E? Interior. Now check this. Angles will give us what? What is 180 minus 130? Child. Fifth angle is what? 50 degrees. Angle is also what? 50. You got to play around. Say, okay, I need to get all of those. Angle B. Angles that are up. What do we know? C1 plus 85 plus. Next thing was to get our E, but we couldn't get E without getting the whole of angle what? Parallel to or is what? 50 degrees. All your steps, opposite angles. What? Palm. All your steps. Now I can consider triangle X would be equal to what? 6 angles in A. Co-interior. Check. So the main thing is you try this, right? I saw it's not working. Aim at those. At get you, boom, you get your answer. So you just need to practice quickly, run through. That you try them, right? And let's discuss. Where interior angle is 90. What I'll do is I'll look at this and write my answer. Then you check on some past papers. So tomorrow, write a full exam and then you mark. Okay.